Every night, over the dark Atlantic Ocean, hundreds of aircraft are flying where there are no roads, no landmarks, and for decades, almost no radar coverage. A tiny mistake in speed or position can matter when jets carrying over 300 people are separated by invisible highways in the sky. So who builds these routes every night? And why do they disappear by morning? And if flying at night seems riskier, why do airlines keep choosing darkness over daylight? Every evening, as North America winds down for the day, a remarkable migration begins in the sky. Flights depart from New York, Boston, Toronto, and other cities, all heading east toward Europe. But this isn't random scheduling. It's a carefully timed operation built around time zones. A flight leaving New York at 10 p.m. can land in London around 10 a.m. local time, despite spending only 6 to 7 hours in the air. Passengers sleep while crossing the ocean and arrive just as Europe's business day begins. For airlines, this timing is invaluable. Aircraft land in time for connecting flights across Europe, Asia, and the Middle East. Today, hundreds of flights cross the North Atlantic every day, making it one of the busiest international corridors on Earth. But if so many aircraft are heading to the same destination at the same time, who decides exactly where they fly? The answer lies in invisible highways that appear over the ocean and vanish by the next day. Every day, air traffic specialists create highways in the sky that don't exist on any map, and by the next morning, they're gone. Imagine driving on a road that disappears every 24 hours. That's exactly how aviation works over the Atlantic. These routes are known as the North Atlantic Tracks, or ENATs. They are rebuilt twice daily by experts in Canada and Europe using aircraft demand, weather forecasts, and airspace conditions. At peak times, more than 100 aircraft can cross the Atlantic within a few hours, so organizing traffic efficiently is critical. Each track contains precise coordinates, flight levels, and speed requirements. Pilots don't simply choose their own path. They request a track and must follow it with remarkable accuracy. But here's the mystery. If these highways change every day, what decides where they appear? And why can one route save an airline thousands of dollars on a single flight, while another wastes fuel? The answer lies in an invisible river of air flowing high above the Earth, one powerful enough to reshape global aviation every day. High above the Atlantic flows an invisible river powerful enough to push a massive airliner faster than 1,000 kilometers per hour over the ground. Passengers never see it. Airlines chase it every day. This is the jet stream, and it quietly saves the aviation industry millions. The jet stream is a narrow band of fast-moving air found roughly 9 to 12 kilometers above Earth. Wind speeds can exceed 300 kilometers per hour. When aircraft ride these powerful tailwinds eastbound, they burn less fuel and reach their destinations sooner. In some cases, flights can save several tons of fuel on a single crossing. But the jet stream never stays still. It shifts north and south, grows stronger, then weakens again. That's why the invisible Atlantic highways must constantly move with it. So what happens when an aircraft leaves these optimized routes and flies far beyond land? And how do controllers track hundreds of jets over an ocean where traditional radar can't reach? The answer reveals one of aviation's greatest challenges. Imagine flying over thousands of kilometers of open ocean with no control tower watching your every move. It sounds risky, yet every night, aircraft safely cross the Atlantic in one of the most carefully managed airspaces on Earth. Once aircraft leave the coastline, traditional ground radar can no longer track them. Instead, pilots communicate using satellite systems, data links, and high-frequency radio. Modern space-based ADS-B technology can now update an aircraft's position every few seconds, even in the middle of the ocean. Controllers don't just monitor location. They assign precise flight levels and speeds to maintain safe separation. Some aircraft may be flying just 15 nautical miles apart, a huge improvement from older systems that required much greater spacing. But here's the fascinating part. With hundreds of passengers on board, what truly determines when these flights depart? Is it safety, technology, or something else entirely? The answer may surprise you, because these schedules are often designed around one very specific passenger. You might think airlines design transatlantic flights around tourists. In reality, many schedules are built around a far more valuable passenger, the business traveler. Consider this. A single business class ticket on a transatlantic route can cost several $1,000s, sometimes generating more revenue than multiple economy seats combined. For airlines, timing is everything. A traveler leaving New York after work can sleep on board and arrive in London early enough for a morning meeting. That's why many eastbound departures cluster in the evening. It's not just about crossing an ocean. It's about maximizing convenience, aircraft utilization, and premium revenue. Even cargo plays a role. Beneath passengers, aircraft carry pharmaceuticals, electronics, and express shipments worth millions. But if weather, air traffic control, passengers, and cargo all influence these flights, who actually designed this remarkable system? Was it created by one organization, or did it evolve on its own? The answer reveals perhaps the Atlantic's greatest secret, a machine so complex that nobody truly built it. Every night, one of the most complex systems ever created comes alive over the Atlantic. And the strangest part is that no single person ever designed it. There is no master blueprint, no central architect. Yet it works with astonishing precision. Over decades, this system evolved through technology, economics, regulations, and human behavior. Aircraft manufacturers built longer-range jets. Air traffic controllers developed safer procedures. Airlines optimized schedules. Airports became global hubs. Piece by piece, an invisible machine emerged. Today, a traveler can leave Chicago in the evening and reach destinations across Europe, Africa, or the Middle East the very next day, through carefully timed connections. Behind the scenes, thousands of professionals, from meteorologists to dispatchers, keep this network moving every hour. So who truly controls the Atlantic sky? The answer is everyone and no one. The next time you look out of an aircraft window at the dark ocean below, remember this. You're not just crossing water. You're traveling through a living system built by millions of decisions over nearly a century. And perhaps that's aviation's greatest secret. Not that it was designed, but that it evolved into one of humanity's most extraordinary achievements. Every night over the Atlantic, an invisible machine comes to life. No single person designed it. Yet it moves hundreds of aircraft across thousands of kilometers with remarkable precision. The secret isn't hidden in one place. It's built from weather, time zones, air traffic control, economics, and technology, all working together. For nearly a century, millions of decisions by pilots, engineers, controllers, and airlines have shaped this extraordinary system. The next time you're flying over the dark Atlantic, remember, you're not just crossing an ocean. You're traveling through one of humanity's greatest unseen achievements. And perhaps that's the real secret airlines don't tell you. Not because it's hidden, but because most passengers never think to look. If you like the video, hit the subscribe button. There are many more hidden stories in aviation waiting to be discovered.